Coming up next on Twitch, This Week in Computer Hardware, we talk about a Battlefield 3 system build guide, some issues with id Software's latest Rage title, and lots of your viewer questions. It's all coming up next on Twitch.
Netcasts you love.
From people you trust.
This is Twitch.
Bandwidth for Twitch is provided by Cachefly at CACHEFLY.com.
This is Twitch, This Week in Computer Hardware, episode 140, recorded October 6th, 2011. Rage. This episode of This Week in Computer Hardware is brought to you by Netflix. Watch thousands of TV episodes and movies on your PC, Mac, iPad, iPhone, or TV instantly. All streamed directly to you, saving you time, money, and hassle. For your free 30-day trial, go to netflix.com/twit. Hi, everybody. Welcome to This Week in Computer Hardware. I'm Ryan Shrout, joined this week not by Patrick Norton, but instead by our very own Allyn Malventano. Allyn, nice to see you.
Hey.
That doesn't necessarily mean we're going to have a bevy of storage stories to talk about. I'm sorry if that disappoints you a little bit, Allyn. And in fact, I don't know if we have any specific storage stories, but Allyn is a jack of all trades. He knows pretty much everything about everything. Well, we like to have him on. Patrick is taking care of some house duties that kind of came up in an emergency situation. So he'll be back next week. And actually, maybe even I'll be able to come up to Petaluma for the studio there, since I'll be in the Oakland, San Francisco Bay area. So again, this show lives on your questions. Twitch at twit.tv is the address where we need you to send that type of stuff to. TWICH at twit.tv. Give us any questions or comments or thoughts you have on the show. We've got a lot of emails and stuff we're going to get to today. But first, we want to go through a couple of news stories, things that happen in the world of computer hardware, technology, gaming, starting specifically with the gaming discussion. We talked in the last couple of weeks, Al, about Battlefield 3 on Twitch. We've talked about it being almost to the level of a crisis in terms of hardware requirements for a PC, whether or not that was good or bad. Now, I know it's probably been a while since you've upgraded your graphics card, right? If I remember your system specs correctly.
Yeah, I'm still on a 260, actually.
Yeah, so if you wanted to play this game, you could do it. I have to say that up front. We did talk last week. We tested it, and it did run on a 9800 GT, which is, you know, a full architecture before your card. So we'll run on the low settings. We had a lot of questions and a lot of clamoring for something like this, though. So I built a Battlefield 3 system build guide, which is essentially a unique and slightly different take on the PC Perspective hardware leaderboard, where instead of targeting a cost as the metric that we need to meet, we're targeting a quality setting and resolution in Battlefield 3. So we have a 1680 by 1050 at medium, 1920 by 1080 at high, and 2560 by 1600 at ultra settings systems. And then we kind of include the processor and the graphics card. What's interesting to note is the CPU is really almost basically the same across all of this, right? You've got the Core i5 2500K and both the kind of the low and the medium, or the medium and the high setting systems. 4 gigs of memory, a Z68 motherboard of some kind. Those are pretty. You know, you can switch those in and out. I think I did recommend. I mean, we went to 8 gigs of memory on the high system because you can get 8 gigs of memory for $47, which that's just way cheap. Crazy. And it's like it's kind of pointless to not. I think the 4 gig kit was $32. The 8 gig kit was $47. And it was just like, well, that kind of sums that up. What's kind of, I think people might be surprised by is if you look at the high system, you know, the graphics cards we're recommending right there are the high-end Radeon HD 6970 Lightning card from MSI, or the Asus GTX 580 1.5 gig card. So those are the top end discrete single GPU graphics cards from both AMD and NVIDIA, and we are recommending those for 1080p resolutions, which we haven't done in a long time, right? Usually if you had a high-end card, you were capable of 30-inch resolutions, and you could just go about it, just turning on everything. Battlefield 3 is a little bit different, and we did see some, our goal were those resolutions and quality settings at 60 frames per second, which is key. And, I don't know, in the gaming that you typically do, Alan, are you one of those gamers that thinks, 35 to 45 frames per second is enough? Do you think 60 and above is the target? I mean, what's your kind of take?
I go for the higher frame rate just because what I've noticed is when you do crank up all those settings and you get the slower frame rates, you also get like noticeably more lag, like especially if you're using triple buffering on something where your system is just not nearly fast enough to support it.
You're talking about like lag between mouse, keyboard, input, and what you see on the screen.
Right, but not necessarily because of like display input lag, which we've talked about, on other podcasts and such in the past. I mean, like where the game engine actually just lags by a few frames, right?
It's an interesting discussion because we could get real dirty and deep down at how these different game engines work, because there's different ways that game engines time slice and how they whether or not they're able to update it higher than 16 millisecond, 16 frame per second cycles and that kind of thing. So, but you're right, it's just better in general.
Yeah, so what I end up always finding myself doing is I typically will just, again, I'm only on a 260, a GTX 260, and and I'm on a 30-inch LCD. So at the same time, I want to run at that native resolution of the panel, right? But at the same time, I have this, sort of a wimpy-ish video card working against me. But I'll just scale back all the settings and I'll see, how it looks, and then I'll just add some stuff to, I go more for frame rate than I go for the detail, because something that I've sort of noticed when you have such a big panel is that you have so many pixels that you don't necessarily need the crazy insane detail for it to be playable, and look at least halfway decent, right? Yeah.
In our Ultra configuration, which is 2560 by 1600, which is your 30-inch panel, or, if you want to go into the triple panel configurations, 31080p displays, we're actually recommending GTX 580s in SLI configuration or Radeon 6970s in Crossfire configurations. And to be perfectly blankly honest with you, I don't even think those two cards in either configuration would be enough to run 5760 by 1080 at ultra settings. I think it would be close, but I think you'd fall under that 60 frames per second mark. But I didn't really want to get into recommending a third graphics card or anything like that. So that was an interesting article. Go check that out. It's at PCPer.com. That's the Battlefield 3 system build guide. That does come out October 25th, so you want to make sure you're prepared when the full game is released. You'll be able to play those larger 64-player maps with all the vehicles and that kind of stuff, which is really fun. The other major game release that actually the full game came out this past week is Rage. We've talked about that a little bit as well. And what's interesting about this game is that it takes a totally different perspective on performance. This is like what I would imagine if Allyn were to design the game, right? You just talked about the importance of frame rate to you and your gaming experience. Carmack sees it the same way. He sees 60 frames per second as the goal, not high image quality, not high anti-aliasing, not any of those other types of things that we normally judge as image quality. He says we're going to make the game run at 60 frames per second, and then we're going to adjust image quality accordingly. So the idea of the game is that if you run it on a 560, you get 60 frames per second at a slightly less detailed image quality than you would if you ran on a 580. In practice, it doesn't really happen all that precisely right now. My understanding from some people at NVIDIA and AMD is that if you have a 560 or 6950 and likely even a 6870, you can run this game and it'll run at the best image quality settings it can possibly run at, and it'll run at 60 frames per second, well above 60 frames per second, if we had ever figured out how to unload or remove the 60 frames per second locks. This video that we're showing in the demonstration here is actually some of the playback we recorded through HDMI output directly, right? So this isn't through fraps or anything. And I'll just sum up my kind of impressions of this game in a couple of quick phrases. In the areas where it looks good, it looks great. It looks really impressive. The texture detail is there. In the areas where it looks bad, it looks like circa 2004 bad. And what's unfortunate is you never really know what is going to look good or bad. Like if you take a look at a city shot from up top, you know, it might look very good, but you'll go down and some of the textures that you'll get close to will be very detailed. You know, you'll see cracks and crevices and things, but then you go to another texture and it's flat. It's, you know, there's nothing to it, and it looks, you know, Doom 3 or before. Actually, there's a funny screenshot that's kind of going around all over the internet and on Reddit and things comparing Doom 3 to Rage. It's obviously an unfair comparison. They, you know, they picked the best of Doom and the worst of Rage to do it. But there are just some instances where this game doesn't impress visually as we kind of expected it to, especially for a 21 gigabyte download, which is a lot. You know, the racing sections are fun. They're not, I mean, this doesn't have that wow factor to it. You know, sometimes when you get into the bigger cities, it does. So performance-wise, there wasn't a whole lot to discuss. You know, Battlefield 3 was focused on what GPU do you need to run this game at the high resolution that you want to. This game, you don't really have to worry about that. Instead now, actually, if we go to the third page of this article, you'll see that the major issue that has come up with this is this kind of texture loading, texture pop-in issue. And if you look at the first screenshot on that third page of the review, you'll see on the right-hand side, the very right edge of it, textures that look fairly detailed. They look pretty good. If you look at the left side, it looks flat, it looks bland. And what you're seeing is the result of, that's a screenshot from a video we captured, where if you turn quickly left or right, what can happen sometimes and on some systems is the textures take too long to filter in from main memory, from the hard drive to main memory to the GPU, and they aren't in full resolution when you first get to look at them. So they kind of have to, I don't know, how would you describe it now, where they kind of fade into focus, they kind of, the detail gets added as you look at it, and sometimes
it's sort of like the way you used to load, you know, back in the dial-up days, how images used to load when they were interlaced or interleaved, right? And
interleaved, right?
So that by itself isn't too horrible, but what's really noticeable is sometimes the textures start like blank, like before you even get the basic part of the texture, and that's what really catches your eye. And just sort of you sort of see this flicker like constantly, like as if you're panning quickly, and you're like, oh, okay, wait, there was something kind of flickering in the corner there, but it's gone now, and it's just the fact that it's repeatable and it's constantly doing it, just sort of, you know, it just might get to some people. Some people might you know, just pick up on it right away. Like I'm sort of sensitive to that, and I was like, wow, that's really, like when I first watched that video you posted, Ryan, that's where, and of course that was under what it was Fraps running initially at the beginning of it, and it was more noticeable there just because there was extra, you know, the system was doing extra stuff and it was making the game sort of delay a little more. But yeah, definitely noticeable. And
it's what happens is, it's kind of weird, right? So on different people's system, it kind of reacts differently, and we'll show this video here. And if I don't know if this is this is the Fraps version, so you can clearly see to the left as I turn that things come into focus. And on some systems, I haven't seen a system where it doesn't happen at all yet, but I've seen some places where it happens. The textures come in much quicker, so only a very small portion of the edge of the screen is actually kind of out of focus at any given time. And you know, you're kind of focused on the middle of the screen. You may not notice it. You may just think it's part of a motion blur effect or something something like that. And on other systems, it's very poor, and it's very obvious that these types of things are happening. And there's, you know, there are, if you go to the Steam forums for Rage, there's a lot of tweaks, a lot of config files that you can download that people are offering up to help alleviate these issues with either NVIDIA, AMD graphics cards. I think it's a lot of CPU utilization issue as well as some potential I/O bottlenecks. Although even people with SSDs are reporting that the same thing is happening. So,
what it almost seems like is happening is the game engine. Actually, John Carmack sort of just gave part of the answer to this, so we don't have to hypothesize too badly. He said if you want to see it at its worst, you know, back into an area of the map and just watch stuff because everything will have to draw, right? So the game sort of in the background, it preloads that stuff, but only the stuff that you're pointing in the direction of, right? So what's weird to me is that if you turn, when you are walking into that scene, you were at some point, like in the very, within the past few seconds, probably, you were pointing in that direction of all those textures, and the game probably loaded them. But the
seems to
weird
get
thing
rid
is,
of them very quickly.
yeah, it's so quick to disregard them, where you could just be standing in the middle of a town center or whatnot, and just pan away, and you only panned away a few degrees to where that object is off camera, and then as soon as you come back, then you have to wait for the stuff to pop in again. That's what's the weird, the weird part of it. It's almost as if they were a little too much cleaning up after themselves as far as memory use, because you have people with memory, with video cards that have a gig of RAM on them, and I'm pretty sure it didn't
what's
need
curious about that is, so this is a 21 gig download. It's a 21 gig install for the game. So there's a lot of texture data there. And what's interesting is he's said in the past that the full textures for this game is about 150 gigs, but they obviously couldn't distribute that in any kind of reasonable fashion. And so that, I think, will address some of my issues where I see like some areas are flat walled and some areas are very detailed. Characters in the game are very detailed, very exact looking, very nice looking, but some areas are not. If you can have 150 gigs of texture data on your computer, the native texture data, I bet it improves image quality a whole lot. Although I bet maybe it makes this whole texture pop-in concern actually worse. So it's something that id Software is working on. We're going to keep checking on too.
Yep. And that part about where some of the textures are really, really plain looking compared to some other ones, it may just be that same engine, right? They had to come up with some kind of an engine to compress that 150 gig worth of texture data into something that they can actually distribute, right? Well, nobody's going to look at the result of that and be able to cherry pick every single thing and tweak that algorithm for every single texture on every single part of every map, right? So there's going to be stuff that slips by. Like some of those examples that we've seen where, some part of some map just looks horrible, right? It's probably just that same algorithm. They had to run it through 150 gig worth of stuff, right?
Right.
So that's probably just the end result of that. I'd imagine they'd be able to just patch, and just clean some of that stuff up probably over time.
Yep, probably. So we'll keep checking on that. And if you are a Rage customer, you can keep checking out the Rage forums on Steam. They seem to be the most active place for help, as well as a lot of whining and complaining, but not all completely unwarranted. A couple of other quick notes here. It looks like, according to a leaked Micro Center memo, Bulldozer will in fact be released on October 12th. This comes from a memo that was actually sent to us by a Micro Center employee, saying essentially that the quote here is, AMD is launching their new AM3 Plus FX series processors on October 12th, 2011. We currently have a number of AM3 Plus compatible motherboards in stock. These motherboards will support the new AM3 Plus FX processors as well as legacy AM3 processors. So they were saying that, the memo out to make sure that their employees knew that if somebody came in asking, hey, will this motherboard work with Bulldozer, they can reply in the affirmative. They also pointed out that it will launch on the 12th. So people who were asking about it, I was able to kind of allude before that it maybe happen in October, it might happen in November, it'll definitely be before the end of the year. Pretty much assured at this point that it's going to be on October 12th, which then leads us into some more leaked benchmarks of Bulldozer. We seem to get these all the time. These are actually slides from what appears to be an AMD Bulldozer kind of press presentation of some kind. And the interesting benchmarks that they're showing are that the first slide there actually looks at gaming at 1080p. And they compare an AMD FX 8150, which will be the top-end Bulldozer part, to an Intel Core i7-980X, which is a 6-core hyper-threaded, $1,000 CPU. And you'll notice that the red bar, which is the AMD part, and the blue bar, the Intel part, are pretty much even across the board. And the reasons for this are obvious, right? Anytime where you have a game engine that is GPU limited, which is basically almost all games, especially if you're talking 1920 by 1080p, and I'm sure they have anti-aliasing and that kind of stuff turned on. The truth of the matter is the processor and platform matters not at all, but pretty minimally in terms of overall gaming experience and gaming performance. So I think that's a demonstration of it. It's a valid point on their part. They're basically saying, look, for $800 less, than the 980X processor. You can buy our processor that will give you the same gaming experience at 1080p resolutions. And I think that's a very valid point, but I think it's a little bit unfair in terms of this is something that maybe we already assume, but maybe AMD's point is not everybody already knows this. So maybe there's some validity to that type of claim, right? Where they're trying to inform people, hey, you don't need to buy a $1,000 processor to get the best gaming experience. You need a balanced CPU and a really good GPU, right? Your GPU is going to affect performance in a more dramatic way than that. And then below that, we had some WinRAR handbrake results, and it kind of shows the FX processor falling between the Sandy Bridge i5 2500 600K. Again, these are probably pretty accurate just based on the presentation and that kind of stuff. But we don't have to wait very long. October 12th, apparently, you guys will be able to know all of that.
That does look pretty darn good, though, that second slide. I mean, the gaming slide, sure, that's just a wash because, you know, the games are the games, right? But the second slide is showing some CPU-intensive stuff there, right? I mean, like WinRAR, that's pure CPU, basically. So just the fact that it could even be on par, and of course, we're not going to know for sure until the 12th, but, you know.
What you'll notice is these are all very multi-threaded applications, right?
Yeah.
And the AMD FX processors are 8-core processors versus quad-core parts, the 2500 without hyper-threading and 2600 with hyper-threading. So yeah, I mean, highly threaded applications will probably do very well on Bulldozer. It's the, our worry is on single-threaded, 2 threads, 3 threads, 4 threads, you know, something like that. Will we see an advantage there? What are the clock speeds going to be, et cetera, et cetera? So
that's true, because that does boil down to, you know, there are still some apps out there that are single-threaded, right? And
oh yeah,
straight line speed basically when you think about it of like one CPU.
Yep. Something else interesting that was being discussed this week is panel self-refresh. Have you looked at this at all, Alan, and kind of understand what they're attempting to do here?
Yeah, it's actually a pretty neat idea. So if you think about just the standard process that your video pipeline goes through, right? You have a GPU, it's calculating for what's going to get painted to the screen, and by painting to the screen, it actually takes a bunch of bits that's the result of what's supposed to get put on your screen, and it puts them in a frame buffer on you're still on the video card section of whatever your machine is, right? And then from that frame buffer, that special kind of memory that can be read from and written to at the same time. So you have your GPU sending bits into this buffer of memory, and at the same time, there's another chip that's just reading that data out, and it's constantly doing that, regardless of what the GPU is doing. So if the GPU locks up completely, there's still a separate engine that's, you know, taking those bits constantly, and it's doing what's just considered the refresh of your screen, right? And nowadays, most people have LCDs, and the standard refresh of an LCD is 60 hertz. So that frame buffer engine is just 60 times a second reading front to back that buffer and sending it out over your, you know, whatever your interface may be, right? DVI, HDMI, whatever it is. And then it goes out, and DisplayPort is what the article I was talking about specifically. And then it goes to your display. Now your display, LCDs don't flicker anymore like CRTs used to, because once you put those bits on the screen, they stay there, right? They don't dim out in between the scanning of some electron beam or any kind of silliness like that, like what used to be. And you also don't have interlacing or any of those other issues. So what this technology is doing is it's like, all right, so say you're just sitting there. Think about your typical user looking at their PC screen, just doing typical things. They're browsing the web, they're working on a Word document, something, right? If you actually think of how much time that screen is completely stagnant, and I mean like not even a pixel moving, right? Or even if you had a couple of things on there that were changing occasionally, you had the clock that was changing the second, well, that only needs to get updated once out of 60 cycles, right? If you're just looking at a static page other than just your clock ticking in the corner, right? So that's like 59 out of 60 frames. You could not necessarily need to worry about that entire pipeline working, right? So, you know, there's a lot of voltage changes that need to happen there. You're reading a lot of bits from memory. You have to re-encode them, pass them over a DVI cable or whatever the cable is, right? That's a pretty big deal electronically to be able to pass that stuff over those interfaces that fast, right? It actually takes a lot of energy when you think about it. So this standard or this proposed kind of thing that they want to do is this panel self-refresh. They call it panel self-refresh. There's probably a lot less to it than that, actually, because it's if you shut down that engine, right? If your screen is just completely stagnant and you just tell the video card, all right, look, nothing's changing. Don't bother refreshing the screen until I tell you that something's changed. So then that engine just shuts off, right? Anything going across that cable, now, provided that cable is it probably has to be something where it lets the LCD know, hey, by the way, nothing's changed. I'm not going to be updating you for a while, right? And then that basically just hands it off to the LCD to just, whatever it was showing on the screen, just keep showing it, right? So in computer terms, that's like a really long time. It could just be sitting there waiting, even though it's like, just 59 refreshes. But if you're able to do something like that, or even say you don't have any clocks or anything on the screen, you just got one page of a PDF just sitting there stagnant on your screen, you got up to go get coffee or whatever, the whole video engine could just shut off. I mean, the whole thing, right? All that's left is just the transistors in your LCD and the backlight, which I think they claim was, up to 85% of the power use of that entire thing. So that's pretty darn significant, right? That's if you're just able to, on the fly, turn that stuff on and off.
Yeah, I think it could be pretty cool. Hopefully, and this was something they actually demoed at Intel, the Intel Developer Forum back in September as well. Again, in their quest for that 24-hour battery life of theirs. So hopefully, we'll see that actually implemented very soon. Obviously, notebooks is the key area there where battery life is very important. A couple of other articles I wanted to point out here before we get into our emails for this week. One is an article over at Hard OCP. Our friend Kyle. And the actual author of the article is Paul Johnson, who's their power supply testing guru. Says his article is titled "Why 80 Plus is Irrelevant to You When Buying a Power Supply." It's kind of interesting. We get a lot of emails in here about power supplies, and a lot of times we discuss what 80 plus, silver, gold, platinum, what these different things mean. And, the first page of the article talks about how easy it is to cheat on 80 plus certification. You can send in a specific unit. You can cherry pick a unit. You can send in one that doesn't have to be UL certified, all kinds of different things. But what I found more important or interesting, rather, was these graphs that they're showing a typical 500 watt power supply or 1,000 watt power supply, and what the, cost per usage, the cost difference in using these power supplies at 20% load, operating for 24 hours versus, how much money do you save if you actually go to an 80 plus gold or platinum power supply? And, let's say, for example, they have the cost to operate 24 hours at 50% load for hypothetical 500 watt power supply. That means that the difference for a 24-hour period is 60 cents for an 80 plus, just a base 80 plus, down to 56 cents for bronze, 55 for silver, 53 for gold, 52 for platinum. So even in the largest case, what you are seeing is an 8 cents per day difference in power cost per 24 hours of 50% load of a 500 watt power supply, which is actually pretty high. I would wager that if you have a 500 watt power supply or a 1,000 watt power supply, chances are you're not at 50% utilization of that anywhere close to the majority of 24-hour period. So, and the same kind of results you get in the 1,000 watt range, the differences go from, the worst possible scenario of 100% load on a 1,000 watt power supply for a day goes from $2.40 a day down to $2.16 a day. So there you're saving, 24 cents essentially per day. And they did the math. How much does that actually save you a year? Saying like $44 a year. But you're going to pay more than $44 extra for a platinum power supply. They gave you a couple of examples. You can get basic 80 plus power supply for $49 and a platinum one for $159. So now you're paying $100 more for an 80 plus platinum that's going to take 3 or more years. And they go in there and they say, look, if you're in it for the green mentality, you want to be, doing your job for the environment, sure, that's not a problem. But don't think that you're going to save money. Don't think that necessarily even the power supply you get is actually going to be 80 plus platinum. It's possible maybe you get one that's not nearly as efficient, and it's actually an 80 plus gold. type setting, right? I mean, there's variance in power supplies, just like there's variance in overclocking capability in processors and those types of things. It's a really good article, and I would encourage you guys to go over there and check that out.
You know what would save you much more than going from that platinum, gold, all those other things. That's like your just basic diminishing returns, right? You're going for that extra, trying to squeeze that extra few percent out. Once you've already saved 80% worth, right? Then that extra few percent, you just spend a lot more money to get there, right? You're actually much better off read some reviews, especially reviews like ours, actually, a piece of perspective, where Lee does crazy efficiency tests on power supplies, right? Where if you look at our reviews, anybody else's reviews where they do that same kind of thing, you'll notice that there's a sweet spot for a given power supply, for a given rating, where it's at its peak, right? Or its peak efficiency. And if you just take 5 or 10 minutes on your system build to try to guesstimate, okay, how much power is this thing going to take? All right, let me try to get a power supply that's just that much, so that my power use sits in that sweet spot all the time. That's your best bet. If you're just building a cheesy, run-of-the-mill system and you go throw in a 1,000-watt power supply in there, it's going to run at its least efficient, really low power part of the spectrum there. And you're just throwing money away, basically, on top of throwing the money away on the 1,000-watt power supply, right? So it's just a easy, quick thing to research if you really want to get into the nitty-gritty, and then just realize that you're going to be saving yourself that money. But yeah, you're right. It's that 8 cents a day only works out to like $30 a year, right? So it's not
right.
It's not a crazy difference.
Let's see. The other article I wanted to point everybody to was actually over at techreport.com. It's actually a news post that they discuss Epic porting the Unreal Engine 3 to Flash. If you go there, if you go to the second video on their page, it's actually a demonstration of the Unreal Engine 3 that Epic Games has ported to Adobe Flash, courtesy of Adobe Flash Player 11, which came out yesterday, the day before. And they're saying they're going to make Flash-enabled Unreal Engine 3 available to engine licensees very soon. So you could see games very quickly. What's interesting is Epic says that the Flash Player 11 with the Stage 3D application programming interface purportedly allows 1,000 times faster 2D and 3D graphics rendering performance over Flash Player 10. So it's pretty cool. If you're watching the video version of it, what you're seeing is really impressive graphics all being rendered through Flash. It's obviously using the GPU as well. GPU acceleration is something that's been in Flash basically since the beginning of Flash 10.0. Now they've expanded outside of just video acceleration, and now they're into 3D acceleration. And it's pretty impressive to see. So maybe there's some life for Flash after all.
I'll tell you what that adds a headache to, though, for some people.
What's that?
Any kind of exploits that deal in Flash. Basically, Flash 11, 10, and 11 they're getting so much to the point where it's not like a scripted or sort of a higher level, like a Java sort of code anymore. It's like much more low level stuff. It's more like assembly level stuff as it comes out of its compiler. It's more like a compiled thing now, basically.
Yeah.
Much closer to like a regular executable. It's just running on your system, right? That kind of a level of, interaction with the CPU, that sort of thing. So that actually, the newer versions of that, they're great for gaming and stuff, but the counterpoint to that is it's much harder to figure out if there's malicious stuff in them. Because the prior versions, you could just sort of sniff that stuff as it went across the wire and go, oh, there's some malicious script in there. I can just pick it out. Now it's so much more like a regular compiled program in itself that it's actually harder to see that stuff now. So good for gaming, yeah, but it's a slight potential ding on security.
Won't bother me at all. Okay, we're going to jump into our allotment of questions and emails for this week. But before we do that, we need to take a quick break here and thank today's sponsor of This Week in Computer Hardware. That would be Netflix. Netflix is the company that will stream you thousands of TV episodes and movies instantly, anywhere you are, and on most devices that you have. You could save time, money, and hassle. For example, I'll give you a perfect example. My wife rented a physical disc from, let's call it a colored machine at a grocery store. Seemed fine, inexpensive, almost convenient. We were at the grocery store already. Not convenient returning the video, because I had to do that the next day. And it's just like, one more thing I got to do. With the Netflix streaming service, you don't have to worry about that. You watch whatever it is you want to watch, TVs, movies, whatever. And because it's streaming, you don't have to worry about taking it back. There are lots of ways to instantly access streaming movies and TV shows with Netflix. You can watch it on your PC, of course, Mac, iPad, iPhone. Lots of Android phones now support streaming Netflix applications. If you have a gaming console, 360, PS3, Nintendo Wii, those support streaming Netflix as well. If you're not a gamer, you can still get a Roku box or an Apple TV, and those have Netflix applications and capability in them, so you can stream directly that way as well. You can watch as many TV shows and movies instantly using any of these devices. And what's pretty cool is you can start watching a show in one location and finish it in another. So this happens to me if I'm watching something at home late at night, I can't finish it. I come into work the next morning while I'm doing some testing. I can turn on Netflix. It'll start that episode of the TV show or movie wherever it was I left off at home automatically. I don't have to fast forward through anything. Let's see. Oh, and you can cancel at any time. I don't know why we even bothered to bring that up, right? Because I think once you try the service, you're really going to like it. It has cool features. There's lots to choose from. Lots of seasons of TV shows. You know, people think of only movies, but it's TV shows as well. That's kind of important. So you can scroll through there and see if there's a show that you always heard a lot about, heard all your friends talking about, but you never actually tried. You can access that on Netflix. You can watch entire seasons that way. It's pretty nice. Now, you can try Netflix today for 30 days, completely free. All you have to do is go to netflix.com/twit, T-W-I-T. Be sure to use that URL when you sign up, netflix.com/twit. We thank Netflix for their support of This Week in Computer Hardware, and hope you enjoy watching instantly with Netflix. So let's jump into our emails. Again, if you want to email us, it is twich@twit.tv, twich@twit.tv. Actually, Alan, why don't you go ahead and read our first email here from Harold.
All right, email from Harold, who has some money to spend. Good for Harold.
It's always nice.
I just got my PFD from the great state of Alaska. Now I'm wanting to spend $250 to $300 on upgrades for my PC. I just want to spend some money. If you had this PC, what would you spend the money on? So he's got a Core i3-2100, a Z68 motherboard, 4 gig of RAM, 1 terabyte hard drive, GTX 460 video card, 24-inch LCD, and Windows 7. So he gives us some sort of choices to go on SSD or go SLI or upgrade the CPU. That's a loaded question, mainly because he didn't tell us what kind of stuff he does with his PC.
True. I do want to point out, I think I had to look this up, and I think we're gonna have curious parties. The PFD is the Permanent Fund Dividend in Alaska. This is the money they give you for living in Alaska. And I checked, the amount of the 2011 dividend is $1,174. And the distribution date is today, October 6th, 2011. So he's definitely got money to spend as of today. He's holding out on us on a little bit with the $250 to $300, but we'll let him slide. So what do we recommend here for $300? You're right. He doesn't really say what he does.
If he,
I think going up to 8 gigs memory is quick and easy. $50.
Yeah, you know, he might be able to knock out like 3 of those things at the same time. And here's how. Core i3-2100, assuming he sold it, if he upgraded, right? He could probably bump it up to an i5 for like maybe 100 or 150 of that when you consider the Delta, right?
Okay.
You know, and then 8 gig of RAM, we already know is like $50, dirt cheap.
Yeah.
And heck, he could probably sell his old RAM and even get some of that money back too if he's smart about it. And then what does that leave him? About $100 to buy a cheap solid-state drive and use that Z68 SSD caching. So you can do basically everything except for the SLI for that $300. And that system will go much faster with all that stuff done to it at the same time. Yeah,
you're right. With what cheap SSD would you recommend in that kind of $100 range? Is that Intel 40 gig drive come into that range?
Well, actually, for better performance, it's just like I think it's 110. You can actually get the real caching SSD, right? That 20 gig of SLC flash memory, which is the dang it, what's the number?
Still 510.
There's a 510 and a 511. Yeah, right? Or 310, 311. Yeah. That's what it is. And one of those is not the right form factor. You just need to get the 2.5-inch version. Or you could just go with, I would still recommend staying with Intel, but if you sort of take a ding on the right speeds, if you get something other than that caching drive. So if you're going to not go with that caching drive from Intel, get some form of a cheap SandForce. There's SandForce 60 gig drives going for like $100 now. And they're really good performance. And just remember that Z68 caching is only effective up to 64 gig. So don't go crazy.
Don't bother buying any more than that. Yeah.
You're just going to waste it beyond that. Yeah.
All right. We have an email from, good luck, Harold. Spend your Alaskan dividend money wisely, or not wisely, I guess. On the Corsair H100. He says, I have a system built with a Corsair 650D case with a Corsair H100 water cooler on top. Currently, I have the fans pushing the radiator out of the top of the case and the rear case fan blowing air out the back. I'm wondering if this is the optimal setup. I've read online people saying they prefer to pull cold air in onto their radiator. However, wouldn't this be bringing a lot of hot air into the case? Would it be good to reverse the rear fan? So this is a more complicated discussion than I guess probably a lot of people realize. The directions of your fans, positive air pressure, negative air pressure inside your case. I do believe on the Corsair recommendations are that the fans are blowing air out of the case over those radiators, both with the H50, 60, 80, 100, all those devices want you to blow air out. And he's saying the back is blowing air out as well. We assume then that he either has a fan in the front or that's drawing all the air in from the front, maybe the bottom. The 650D does have air intake on the bottom as well. Alan, do you believe that there's a performance difference capability there?
Well, so let's try to get the visual right here. So he's using the Corsair H100, which is the water cooler, right? And he says he has it mounted.
It's the dual 120.
Okay, so he has that mounted at the top. Well, like the rear top, in other words, or
no.
Actually,
like it's in the top. The top of the case.
top. All right. So any water cooling setup, you would typically have, like my take on it is, and actually my own case sitting right here, which is water cooling, fans in the front are sucking air in. Fans in the rear also sucking air in, because you just want cool air coming in from all directions if you can. And then the fans at the top are blowing straight out the top. And that's just natural. It's heat. Heat rises, right? So you get that cold air coming in from both directions. It actually makes it easier for some of the cleaning stuff too, because you can clean, hopefully there's a grill at the rear too. You clean that off. You clean the front and the rear when you're getting rid of all the dust and everything, right? Yeah, because if you think about it, at the rear of the case, that rear fan sucking the air in is probably pretty close to the CPU and actually the voltage regulator, heat sinks, that sort of stuff. So if you have that fan just sucking the air out, you're actually drawing hot air over all those other components. So if he's water cooling, he's probably overclocking a little bit, which is actually going to heat up all those VRM heat sinks that much more, right? It's best to just have cold air hitting those suckers head on, if possible.
Sorry, I had to get up and head away. Batteries died on one of my microphone packs here. I'm back, though. You can hear me?
Yes, we can hear you now.
Okay. I lost you guys. I have a wireless. This headphone is actually wireless, and I sprinted out to find some new AA's pretty quickly, I thought. Okay, you want to take read our next email from Steve here? Because he is asking about SSD.
Yes, that's right up my alley. Email from Steve about using SSDs in a desktop versus in notebooks. Great show, my fave on Twit other than Leo's Tech Guy show. Sweet. I'm curious if you think there's any real advantage to running a small solid-state drive in a machine that runs 24/7. I run Linux Mint on my main machine on an 80 gig solid-state drive with a home folder on a 2 terabyte mechanical drive, which is smart. My Windows 7 gaming machine is similarly set up with most programs installed to a mechanical drive, and it also runs 24/7. I can't say if I can detect a significant performance difference over the purely mechanical drive installation. I did, however, notice a big improvement over after I upgraded my netbook to a solid-state drive, SSDs add complexity to desktop OS installs due to the need for 2 drives. So I wondered what your thoughts were. Thanks again for the awesome show. So what sort of complicates this a little bit is he has a pretty, I'm guessing, maybe even smaller than 80 gig drive in his Windows 7 machine, which forced him to, or for whatever reason, he says he installed some apps and his other stuff onto the mechanical drive. So he's actually losing a lot of that benefit of the solid-state drive, right? So for Linux is pretty darn good about the way that it, like if it's run constantly, it caches things differently than Windows. It's, chances are if you've run something once, that's the only time it runs slow. It tends to keep that stuff in memory much better, that sort of thing. Programs have a smaller footprint. So Linux has a lot of things going for it on that front, to the point where 24/7 operation SSD doesn't give you that big of a noticeable jump, unless you're doing really crazy out there stuff like you're recompiling the kernel or you're doing things that, have a lot of random disk I/O. Then you notice that difference. Windows 7 is a bit of a different story. Your best bet on Windows 7 is try to fit as much of that stuff onto that SSD as you can, because that's what's going to give you those performance boosts when you go to run whatever that is, right? So it's sort of a tough call on that. For Windows 7, I would say if you're running a Z68 board, maybe shift that SSD over to caching duties and see if that makes it seem faster for you, because then it'll end up just caching those bits and pieces of things that are on the hard drives, as opposed to trying to dump the entire OS on there, swap file, page file, hibernation file, all that stuff, right? That might help. Netbooks, the big reason you notice a huge difference is mostly because of the kind of stuff you're doing on a netbook, right? Your netbook is not running 24/7. When you're done with it, you don't just sit it there idle with all that stuff still in RAM, and it just so when you go pick it up the next time, everything's still cached. Not really the case with the netbook, right? You're shutting it down, it's hibernating, whatnot. So on that front, you notice a difference. Also, just the fact that the SSD has much lower latency to it, combined with the netbook tending to have like lower power and, maybe not as powerful of a CPU, it just sort of helps it get things done a little bit faster, right?
Without a doubt.
Yeah. And it's just especially noticeable in a netbook when you go, especially the other thing to consider for the netbook is you probably upgraded the netbook from a very, very slow mechanical drive, if it even had one in there to begin with. But if it did, it would be painful. Trust me. Because those, those really small form factor drives, right? Whereas in your desktop, you're comparing that same SSD to probably a much higher performance, right? If it has like a Caviar Black or some 7200 RPM drive in there, it's still, it's not as big of a jump basically from like the netbook's really slow solution, right? So yeah, I mean, what our thoughts were is, I don't know. My thoughts, I put a solid state drive in whatever I use. Really.
Yeah, I'm still firmly on that side of the discussion as well. And I have some personal issues with SSDs and in some cases have had a couple of dead ones myself. I know we've had discussions about that here on the show before as well, but I still think that the benefits outweigh the potential negatives. Have a good backup plan, all those types of things. So let's see, we've got an email from Josh who's asking about tablet versus standard notebook computers. Says, I'm a college student and I have been saving up for a laptop the past few months. I was looking at getting a Lenovo ThinkPad X2200 tablet. I had my eye on it because of the touch features, looking forward to Windows 8. Is it worth getting a laptop like this or just getting a normal non-touchscreen laptop? I know I was looking far into the future, but any advice would be great. So this is more of an opinion question than any kind of fact question we can help you with, Josh. But I think the Lenovo ThinkPad X220 is actually a pretty good Windows tablet. If, however, you're interested in that, if you're interested in Windows 8, I see no reason to jump into touch-based hardware before the operating system's release, unless you have a specific use for it. Other than that, he says he's a college student. I don't know how much actual touch computing usage you're going to get out of the X220 necessarily.
If he can hold
my personal opinion is to save money You know, if you need a laptop now, you have to buy a laptop. If that's kind of what you're doing, then yes, I think you get the less expensive. You get the X201 or the X, you know, whatever it is you want from Lenovo, because they do make really good machines. That's what I use today as well. The tablets just, you know, they work if that's what you need to have. But if you don't need to have it, if you're just looking for, ooh, I want to have something that's like cool and pretty and gadgety, I would save your money and wait for when Windows 8 actually comes out, because I think you will see a whole new generation of technology of Windows-based tablet devices at that point. Something that maybe
much cheaper.
You know, I think you're right. I think they'll be much cheaper as well. So that would be my personal recommendation is I would not get the X220 today unless you had a specific need for a touch application today. Instead, I would save, you know, you're going to save $400 or $500, something like that, maybe $300 or $400 going for a similarly spec'd and sized non-tablet laptop, even from Lenovo, because I looked at some of the tablets, the touch tablets not too long ago as well. But yeah, I think that's the way to go. We do have another email from David about notebooks. If you want to read that for us, Alan, it's similar, but more focused on gaming side of things.
All right, small gaming notebooks. I've never purchased a Windows laptop before, as I've always been primarily a Mac user, and any Windows machines I build are strictly for gaming and for looking at how awful the websites and design look like in IE. Oh, that's funny. In fact, the only laptop I have owned is a G4 iBook when I was in college, mostly because I was never able to justify the cost of the laptop when most of my time was spent at home or in the office. Since that has now changed, I can justify it. I do not play first-person shooters at all, so the need for extreme twitch is unnecessary. I play mostly real-time strategy, RPGs like Diablo 3, Torchlight, StarCraft 2, Elder Scrolls, etc., etc. I also want something small, which is kind of weird because you'd figure you want a slightly bigger screen for that kind of stuff. All right. I don't need a huge screen, nor do I want the weight associated with it. While at PAX East, I saw a lot of booths were set up with Alienware M11X machines. Actually, we saw some of those at QuakeCon. They're pretty good. And I thought these were pretty slick. Yeah. What is your opinion of these machines? Are they only available in 11-inch gaming machines? I would go up to 15 inches if it means more bang for the buck, but I would prefer to be on the smaller 11 or 13 inches. I also often attend small 20-person LAN parties that are often only a day or two in length. Only a day or two for a LAN party. Wow. Geez, what happened to a few hours,
your game, Al.
right? Yeah.
Step up your game, Al.
Used to just be an evening. All right. A small machine like this would be perfect for the smaller events. That hauling my tower and 27-inch display is often a hassle for a sub 48-hour event. That still kills me. Sub 48. I didn't know that was a metric for LAN parties. I thought QuakeCon was just crazy because people were there gaming for 3 days straight. Yeah, and actually at QuakeCon, we saw those, right? We saw a whole bunch of those sitting out there at QuakeCon. They're powerful little machine. I was surprised.
Anytime I actually recommend an Alienware machine, people email us and give me crap for it. Alienware's desktop PCs I probably wouldn't recommend. Their gaming laptops, though, are about as good as you can get in terms of not only performance, you know, they're nice aesthetically, I believe. Some people think they're kind of gaudy. But from a technological standpoint, they have some of the best products, and they're not super crazy expensive either. The M11X that he mentioned starts at $999, right? And those all come with discrete GPUs. I'm looking here. Let's see, what do we got? NVIDIA graphics, up to 2 gigs of frame buffer on those cards. What GPUs are they? The GT540M. So, you know, a reasonable gaming machine would definitely be able to play those games that he's talking about. He wanted something slightly bigger. They have the M14X, the M17X, and the M18X. Now, the 17 and 18 are those giant, enormous machines that he doesn't want to have to carry around. I think maybe a good medium for him to look at is that M14X. It starts at $1199. I think in the next 2 to 3 years, gaming laptops are going to be much more popular than they are today. I think people are going to realize that the performance you get out of a gaming laptop is going to be, it's going to meet your expectations, kind of your goals for PC gaming. I don't know if we'll ever get to the place where you can update your graphics card on your laptop like you can on your PC, which is something that, we've all kind of hoped would happen. I don't see it happening. So the M14X, I'm just kind of looking up some specs here, starting at 6.5 pounds. So with the 8-cell battery. So depending on whether or not you think that's excessive or not, 6.5 pounds, but it does come with the GeForce 555M graphics. So I think that's kind of a good kind of middle ground there if you're looking for a gaming machine. And then the M11X starts at 4.5 pounds. So the M11X is a very impressive machine. If you want a small gaming laptop, you can bring like a 24-inch display. It kind of gets away with the whole idea of portability of your gaming rig, but you can do that, right? And bring an external keyboard or an external mouse, those types of things, and just not have the tower. But I actually do like the Alienware M series of notebooks. We have an M17X. I don't know where it is. It used to be sitting right here on our desk, but it's big, but it's powerful, and we were playing Battlefield 3 on it at 1080p resolution, and it wasn't really kind of batting an eye. So that's,
I was shocked.
I think that's a pretty good recommendation.
I saw an M11X, actually the 11-inch model, and it was just sitting on a table. Somebody was playing StarCraft StarCraft 2 on it, and it just like stopped me on my tracks because I was like, wait a minute, that thing, that's just like a cheesy netbook looking thing, and it's running this just full bore. It was like smooth too. I mean, not laggy or anything.
Nope. Let's see. We've got an email from Aaron about HDMI latency going from a PC to a TV. A little bit of a longer email. He has a home theater PC that's used for XBMC and PC games in the home theater room. In any given game, there's considerable lag between any input and a response on the screen that doesn't show up when testing with a cheap Scepter 19-inch panel connected via DVI. Basically, he's saying there's a lag between input on the controller or the keyboard or mouse and what shows up on the TV versus what shows up on a directly connected monitor. The problem persists when I play games on the Xbox 360. I need some input on the lowest latency configuration possible. Currently, the PC is connected to the receiver via HDMI, and then the receiver to the TV via HDMI. The receiver is configured with every video option turned off, but it's hard to be certain since the receiver's interface is one of the worst I've ever encountered. There's no game mode that I can find. The TV has game mode turned on, and every feature I can find turned off. In general, does HDMI introduce latency? Is this a known problem with the TV or receiver? What is the lowest latency, most direct digital link I can use? I'm tempted to tear into my setup and recable the PC with DVI. Will I lose HDCP? Even though I strongly believe developers should be wrapped in barbed wire and shot into the sun, I use Power DVD 8 and watch Blu-rays through the PC. He does mention his monitor is a Samsung 46-inch 120 hertz LED backlit LCD, and the receiver is a Denon AVR 591. Bought based on Robert Heron, Patrick Norton's recommendations. So I'm curious.
So I think
my experience with HDMI is no latencies.
No, that's not what's adding the latency, especially since it's not his home theater PC because you can narrow it down because it's also his gaming console does the same thing, right? This is specific to the TV. And I'm not sure if it was this exact model, but man, it rang a bell. Because I think at one point I was thinking of getting that. You got to go through forum threads. Google for that model, dig around. I did some digging around while Ryan was reading. I couldn't turn up the article, but I think that's a model that has a specific sort of a trick mode that you have to put it into, because otherwise the screen is doing all of its processing on that video that's coming in, and it's going to lag by 2 or 3 frames, right? So that's what, 17 milliseconds times 2 or 3.
To 35 to 40 milliseconds.
Right, and it does that all the time except for a game mode. Most TVs will have some form of a game mode.
It said he had his TV in game mode.
That's the thing. It's not, sometimes what's called the game mode doesn't, like, you have to do something else.
Yeah.
Like there's another setting on top of that you have to change. Sometimes it's like you can't have it doing any kind of 120 hertz or true motion or any of those other, every TV has its own tricks, right? But yeah, there'd be some other thing. You like 9 times out of 10, there's some other trick. You just have to.
My
like,
first thought is, these 120 hertz big LCD panels are doing a lot of interpolation. You're not feeding it 120 frames per second. It's not reading 120 actual frames from your PC or your Blu-ray player or whatever else. It's definitely doing signal processing on that side. When it's from a movie, it's not really an issue because it handles both the audio and video, and it delays things however it needs to delay things. With the game, I mean, this is the same issue that came up when the Guitar Hero games were very popular, and DLP TVs, and the same thing. You had a lot of video processing, and especially where a game where it was all timing based, visual, audible, all that type of stuff, definitely became an issue.
The place to go is AVS forum. That's where all that.
That's a great place.
Posts. Yeah.
And also, make sure it's not. Remember, he's passing it to the receiver and then to the TV. So a simple check would be plug it directly from your computer to the TV. See if you see the same latency.
Yeah, because his receiver
if
might
you
be.
Don't, it could be the receiver.
Yep, it might be trying to scale even if it doesn't have to scale, right? Or interpolate or whatever the receiver. Receivers do all kinds of tricks with the video feed these days. As a matter of fact, yeah, I would never pass any kind of gaming thing through a receiver, even if it said it was passing us straight through, because it's still going to give you some lag.
In my setup at home, actually, I go through a dedicated video processor. I think it's a VP50 is the model on it. I can't remember what the name of the company that makes it is, but I bought it years ago, and it's responsible for scaling the Wii and at the time the PlayStation 2 up to a 1080p resolution to pass the TV, because it did a much better job at that scaling than the TV did directly. But it was marketed and sold as a very super low latency device, and you passed audio through it as well. So I'm tempted to say look at that the receiver as a potential issue there as well, because I didn't even Google those results. So I don't know. I something in there is obviously messing it up. It's easiest check is to hook it up to the TV by itself. You won't have the surround audio necessarily or anything like that, but just see if it works. See if that's the issue, and then you cut down one side, and if it still happens, then it's the TV. If it doesn't happen anymore, then you're down to the receiver, and it's time to do a little bit more.
And the TV itself may have, I don't know specific to that model, but it may have an optical audio out on the TV. So in other words, it just splits off the audio stream, and you still can get the DTS. You just need to get an extra toss-link cable and just, feed it back to your receiver when you're gaming.
Yep. All right. I think we've got, let's see. Let's do time for one more quick email. I'll go ahead and read this one from, how would I pronounce that? Eliezer, I guess. Eliezer. Sorry for mishandling your name there, Eliezer. I'm going to go with that. Question about notebook GPUs, pretty direct to the point. How important is a video card for a non-gamer? My old Inspiron 1505 is slowly falling apart, and I'm thinking about getting a new one. Nowadays, when I go to Dell and other online retailers, I can't seem to find a cheap laptop with the add a video card option for about $80 to $100. Like he used to. Like he said before, he's not a gamer, but he's old school. He used to have a video card. My main uses will be web, email, simple photo editing, and the occasional TV connection via HDMI to play H.264 video. Do I still need a dedicated video card? How well will the superb Intel HD graphics serve me? And he links to a machine over at Best Buy that's like $500 using a Core i5 and integrated graphics on that. I think this one's pretty...
Is that the new i5 with like the Intel 3000 series GPU on it?
I do believe so. Yes, it's an Intel. It's a Sandy Bridge part, so it will have it. I mean, for his purposes,
absolutely superb.
Yeah, it is superb in the full quotations of the word, right? And for $479, this is the kind of machine. Maybe this will insult him. This is the kind of machine that I would buy for my mom, right? Because she's doing things like web, email, simple photo editing, and not even a TV output type of thing. But she's definitely not doing any gaming. She doesn't need high-end graphics for anything. And the unfortunate part for AMD's discrete business and for NVIDIA's discrete mobile business is that integrated graphics on Llano and integrated graphics on Sandy Bridge are more than competent for those everyday tasks. And they're cheaper, they're power efficient. It's hard to go wrong on that kind of stuff.
Dare I say, you can even go down to a Core i3 with the slightly less superb, also Intel integrated. It's actually a slower clock rate on the i3s, right?
Mm-hmm. Yeah,
but it still handles Blu-ray 1080p out via HDMI to a big panel. It does all that. It does it just fine.
Yep. It will without a doubt. So there you go, ladies and gentlemen. That's going to wrap up this episode of This Week in Computer Hardware. We, again, please encourage you to send us your emails, twich, TWICH, @twit.tv. Alan, thank you for filling in for Patrick. He greatly appreciates it. I greatly appreciate it. Hope you had fun.
It was fun.
Answering questions and stuff. Thanks, everybody in the chat room, for hanging out. If you want to watch us record the show live, you can absolutely do that. We positively recommend that you do so, because you get some of the pre and post show banter as well. That live.twit.tv, and we record it every Thursday at about 9 p.m. Eastern, 6 p.m. Pacific. So tune in there. So we will see everybody next week. Hopefully we'll have a full regular show there. Like I said, maybe we'll all even be up in the studio next week as well. So this has been another episode of This Week in Computer Hardware. Talk to you guys later.